Good afternoon, gentlemen. Ladies are not available, so just good afternoon, gentlemen. Welcome to my presentation, RIEGL's cutting-edge LiDAR technology in combination with new software modules for data processing automatization in mining. My name is Thomas Geisecker. I'm Senior Manager International Sales at RIEGL, and in this function, of course, responsible for marketing and sales, but also for training and support of our customers. Let me give you a short overview on the presentation. I will speak in a few words about the RIEGL company profile. I will then focus on our product portfolio, especially for terrestrial mining, for terrestrial laser scanning in mining. Thereafter, I will give you some field data examples on different applications. And finally, I will speak in a few words about the software RIEGL, which is the next step in data processing for mining applications. The RIEGL company was founded in the 1970s, so we have almost now 40 years experience in laser range measurements, and we have also developed the first 2D airborne laser scanners in the 1990s and also the first terrestrial 3D laser scanners. And during the next decade, we have established 4 different divisions in our company. This is terrestrial laser scanning, airborne laser scanning, mobile laser scanning, and industrial laser scanning. Today, we will more or less focusing on the terrestrial laser scanning. RIEGL company is an Austrian company, so our headquarters is near to Vienna, just north of Vienna, but we are running also subsidiaries in Orlando, Florida, responsible for the US and Canadian market, also in Tokyo, Japan, and since last year, not even here on the map, but since last year, we have also an office in Beijing, responsible for this fast-growing Asian market. And you see the yellow triangles here all over the world. These are our local distributor partners being responsible for the local markets. Here you have an overview of our 4 different terrestrial laser scanners, which cover almost every application for terrestrial laser scanners because they are covering almost every range. Our VC400 starting with a maximum range of 600 meters. Our competitors call this already long-range scanner. We call it short-range scanners because we have scanners up to 6 kilometers range. So the VC400 is our working horse for many, many different applications. It's because of the high precision and accuracy. It can be also used for short-range indoor scanning. Here in archaeological application, the catacombs of Rome were scanned with that scanner, but also it is very simple to use, so it's also used by the police for car accident scanning and crime scene scanning. And the advantage is the scanner can also work under harsh conditions, in all weather conditions, in rain, in snow, in foggy conditions. It's waterproofed and therefore also used for the documentation of the accidents here, but also for industrial applications, for road construction and road scanning. Next application is tunnel scanning. Also here we have again harsh conditions, high temperatures, low temperatures, wet conditions. And of course also for architectural applications, for facade scanning, and so on. And last but not least, also for R&D project for robotic applications. And here, a very nice application from a customer mounting the scanner here on this special car for scanning ski tracks in the Alps. Then the VC1000 with the maximum range of 1.4 kilometers. This is now the instrument really for mining applications. Here the scanners are used for the everyday surveying, for extracting break lines, for calculation of volumes, and then bringing the data into their mine planning software. But it's also used for long-range infrastructure management, for example, for this scanning of this bridge, because you cannot go closer, so you need the long range of the instrument, but also in mining finally for monitoring applications. Here the scanner is mounted on a concrete pillar, scanning all the time this big wall and running in the background remonitor software, our monitoring software for automatic alarming if there is some movement in this area. And last but not least, here in exotic application, we have also scanned lava streams from a volcano in Hawaii, and it's very interesting because it's a very hot surface. It has radiation in the nearby same wavelength as the scanner is working, and even under these very bad conditions, we get really good measurements on this surface. The next two scanners are really niche range scanners for extreme long-range applications. Here, the VC4000 with a maximum range of 4 kilometers. These scanners are working in the biggest open pit mines because here it's really important to reach the opposite side of the mine. If you cannot reach it, you would need hundreds of scan positions to cover the whole pit, and then it's ineffective laser scanning. So if you can reach the opposite side, you can cover everything with just 3 or 4 scan positions, and then laser scanning is really effective. Also for long-range topographic surveying, here an example, very nice, the Grand Canyon in USA, but also for monitoring in the mountains, always if you have to reach from one side of the valley, the opposite side, because with that long range, you have also a much better angle of incidence of your laser on the slope, and you can cover a much larger field of view from a long distance. Therefore, this instrument is very important here. And finally, we have the VC6000, and I must say here was the focus not on increasing again the range. The focus was to offer an instrument which gives long range also on snow and ice. This instrument is used for snow height measurements, for avalanche risk monitoring, for glacier monitoring. Here, very nice example from an application in Greenland, a very huge inland glacier field. And we must say this is the only terrestrial laser scanner from RIEGL which is not working in laser class 1. It has laser class 3B. So with this instrument, you must be carefully close to the scanner that nobody is looking directly inside the scanner into the laser beam. But with all the others, they are working in laser class 1, which means completely eye safe under all conditions, and also the laser itself is not visible. A brand new system which fills the gap between terrestrial laser scanning and mobile laser scanning is our new VMZ system. So for example, if a customer has already a terrestrial laser scanner VC400 or 1000, it can be seen as a part of a mobile laser scan system. We are offering the whole bottom part here, including an IMU and the software solution and everything, and then you have a real mobile laser scan system. Even the camera on top of the scanner, which is normally used in static mode, can be also triggered with the GPS signal and can be used in the mobile mode. And then it looks like that, or on the vehicle like that. The scanner can be operated either in 2D mode or even while driving in a 3D mode, scanning very quickly, let's say every 10 seconds, a 360-degree scan while moving, and also the camera can be used. So this is a whole mobile laser scan system, and we are using our software products, which we also use for the high-end mobile laser scan systems and airborne laser scan systems for this system. And very nice, you can dismount the scanner by just using these 4 quick action screws within seconds. Use it then as a static scanner and, for example, remount it on the platform and immediately start mobile laser scanning. There is not any calibration of the system necessary. Next thing is, in all our terrestrial laser scanners, we have integrated additional sensors. All of them have already an inbuilt GPS, inclination sensors, magnetic compass, which gives you in the field fully out any targets or markers already a rough orientation and registration of the scan position. And thereafter we are using the overlapping areas for a full automatic alignment, which delivers then a full registered point cloud, again with one mouse click and without any targets in the field. The long-range scanners VC4000 and 6000 have already an inbuilt camera. This camera just covers a small field of view, just 6 by 6 degrees with a 5 megapixel camera, but it's using a very long focal length, which means if you acquire the whole 360-degree images, it's acquiring around 700 images, which means you have in long range also very high resolution on the images to colorize finally your scan data. But all our scanners can be also equipped with an external mounted camera here on top. We have here a special mounting platform which gives directly the scan data, which feeds in directly the image data into the scanner via a USB interface. And also the camera gets the power supply directly from the scanner, so it needs no battery inside. And also the camera control itself can be made with the interface on the scanner, or even by using the wireless LAN with any tablet PC. So if the scanner and the camera itself cannot be touched, you can use a tablet PC and having full control also on the camera. If the accuracy of the inbuilt GPS is not enough, because it's just an L1 receiver delivering 1 to 2 meters accuracy, we can also mount any external high accurate GPS like Leica, etc. We're just using the RS-232 interface, feeding in here directly into the scanner the NMEA string, which delivers, if you have radio control to a base station or a service provider giving you correction data, it delivers directly centimeter accuracy in the mining coordinate system or whatever. And you don't need then finally the handheld for the GPS in the field, because this can be done by the scanner. You can see on the scanner screen directly the number of satellites, the accuracy, the user coordinate system, and everything which is necessary. And the data, again, is stored directly with the laser scan data together. And the newest development, and very interesting for many other applications, is that we can integrate any other image sensor on top of the scanner. For example, here a camera or a hyperspectral camera for geological applications. These cameras are normally using a so-called GIG-E interface for controlling and downloading the data. And we can mount this interface directly on our standard USB port. So also these sensors can be fully controlled from the scanner. These sensors are then calibrated, delivering a calibrated image which can be used directly for colorizing the point cloud, again without any further software interaction. You see here a nice example. I was with the VC6000 here in South America on a long-range scanning, and the first image shows here now in grayscales just the reflectance values from the scanning. The next shows the true color information, which is now on the beamer not very good, but this comes from the internal camera, and the next one is the thermal information from the external mounted camera. So let me show you some field data acquired with our terrestrial laser scanners. You see here the VC4000 in one of the biggest open pit mines, which is in South America, in Chile, in the Andes. The scan position here was approximately 3,000 meter elevation. The top, the bottom of the mine is around 2,000 meters. So we have here 1,000 meter elevation. The top of the mountains are between 4,000 and 5,000 meters. And the whole pit was just covered by 3 scan positions. You see here the first scan position, and this is the scan data from a bird's eye view, colorized, false colored by range, and you see we got even more than 4,000 meters, up to 5,000 meter range. This was scan position 1. Here the scanner was on scan position 2, that's the scan data from scan position 2, and finally from scan position 3 here. So the whole pit was just covered by these 3 scan positions, and as I said before, the internal sensors, GPS, inclination sensors, and compass give already automatically the registration, and then the final alignment is done by the overlapping areas. And finally, we can filter all the objects, triangulating the surface and getting this final accurate triangulated model of the pit, which is covering here nearby 3 kilometers by 2.4 kilometers. The data acquisition needed for each scan position, just 20 minutes. So the data acquisition itself was 1 hour, post-processing just half an hour to get this final result. Another thing is our scanners deliver multiple target capability, which means we can detect on a single laser shot multiple targets. This is a mining example from South Africa. The whole wall is here endangered by rock falls, so they put a big wire on it, but they still want to monitor the surface below. So all these mines have radar technology, but they cannot penetrate these wires with the radar technology. Our scanners can do it. You see here the scan data colored by reflectance, and you see all the areas covered by wires give very low reflectance, because these wires are just covering a small part of the laser beam, so they have very low reflectance. But we can penetrate these wires. You see here classified the data by the type of target, and all these wires are indicating first target, which means we have targets behind. If we show just a small band here and look from the side, we see we detected all the wires, but we have the whole surface behind. So this means you can penetrate such objects. This means also on vegetation, we can penetrate vegetation, and if you have harsh conditions like rainfall, snowfall, fog conditions, also here the laser beam can penetrate this atmospheric situation and still get high accurate data on the ground. Another nice thing, just very shortly for geological applications, you see here a 3D triangulation of a rock face. Extract here the normal vectors of the surface and put this, for example, directly in some special geological software products for defining the joint and fault directions and all these things. So again, these normal vectors can be extracted automatically from our scan data. And also in open pit mining, very interesting, we can calculate so-called cut and fill volumes. We can make a comparison between two surfaces. You see here a big landslide showing here, indicating the zone of erosion and the differences in height and the cut volume, and then finally the zone of accumulation and the fill volume below, which is differing a little bit. Of course, this is also in mining and in blasting. Before it is compact material, and after the blasting it has a larger volume. But we can visualize this data and calculate these volumes. Finally, in a very few words, our software RIEGL for a full automatic workflow, automatic data registration, filter algorithms to filter out objects, trees, to get the real terrain. Finally, feature extraction, contours, profiles, break lines, surface comparison. And we see here just very quickly the data comes into RIEGL from different scan positions. We are using the GPS data, inclination sensors, compass to get automatically a data registration, as you see here on the button, as an animation, which is not working at the moment, doesn't matter. Finally, we have the registration to the filtering of objects, here showing in red all the machines, everything, to remove this data, and finally to create a correct digital elevation model by triangulation of the scan data, and feature extraction like break lines or toe and crest break lines fully automatically again, and profiles, contour lines, data export is also possible to mine planning softwares like Serpec, DataMine, or Vulkan software. And I have forgotten to mention meshes, volumes, which we have seen already before. That's all for the moment from my side. Thank you for your interest. And if you have any questions, our booth is directly outside, just on the right side. I can give you here deeper and more detailed information. Thank you.